So this last bit it looks really complex, but if you know the 3 different rules for asymptotes, it's pretty easy. So let's move to the graph. Okay, so first off, hang on, let me go back one screen. All right, so I'm going to write the rules as we go along. The vertical asymptote is going to be I an F. Let's make sure I give mine the right one. You guys have F, right? F, okay. All right, so vertical asymptote, vertical line, horizontal line, asymptote, horizontal line. Okay, so vertical asymptote is where it is undefined. Okay, and so in this case, it's x equals 0. So there's our vertical asymptote. And then horizontal asymptote. There's 3 rules that go with this. If the degree on top is less than degree on bottom, you have y equals 0. If the degree on top is equal to degree on bottom, it's going to be y equals a over b, and I'll explain that when we get there. And then if the degree on top is greater than the degree on bottom, we don't have one. So this has a horizontal asymptote at 0 here. And then we have to think, is there any x-intercept? Is there any way that we can solve for x? So if we said y equals y over x, is there any way to solve that? If I multiply both sides by x, I get 0 equals 1. So this is no. So there's not a x-intercept. A y-intercept would be, what would happen if I put 0 in for x, and that's then undefined. So there's not a y-intercept in this case. So then you have to kind of decipher, what is this graph going to look like? And what I would say is revert back to kind of a t-table if you don't see anything right away, and plug in 1 and see what happens. So if I plug 1 into this, I get 1 over 1, so 1 comma 1. What would happen if I plug 2 in? I'd get half. And so this side's going to do this. But then let's pick the left side of the vertical asymptote. So let's pick -1, plug it in. So if I plug -1 in, I get -1 out. So -1, -1, this is down here. So this will actually mirror the image over the origin. And that's what our situation is going to look like. So for the most part, our graphs will look something like that, where we have a vertical and horizontal asymptote. It is possible that you have multiple vertical asymptotes. You will not have multiple horizontal asymptotes. There's one other asymptote that I don't know if we will get to it or not, but it's called, there's 3 different things they call it. They call it an end behavior asymptote. They call it a slant asymptote. Actually, there's only 2, end behavior or slant. And that just means if you go out to the right or to the left forever, where do we approach it? But we're not going to see vertical or slant or end behavior asymptotes on these. It's more of a pre-calc idea. So hyperbola. Okay, so a hyperbola or a hyperbola is what we just looked at. Okay, you have asymptotes, often vertical and horizontal. Domain and range have values that do not work. And then it has basically 2 symmetrical parts. So there's some sort of mirror image, and the mirror image does not have to go, across the origin. It can go across the vertical asymptote as well. So we'll see some of those. And a lot of times, a lot of these, they just come down to where things could be equal 0. So this one has a vertical asymptote at x equals 0. And then the horizontal asymptote. So one thing I didn't say before is this the same thing? Is x raised to the 0, it's equal to 1, right? So is the degree on top bigger or smaller than the degree on bottom? Is the degree on top bigger or smaller than the degree on bottom? Smaller. So we have y equals 0 is our horizontal. And then x roots, well, there's no way to solve it. Y roots, in this case, no, because our asymptotes happen to fall right on the x and y axis. Now, it is possible with these that we can, from time to time, cross the horizontal asymptote, but there's weird characteristics that have to take place, and we'll probably see it. But again, if you're not sure what the graph looks like, think about what would happen if you plugged in some value. So on this one, maybe I'd plug in a 3, so I'd get 3 over 3, which is 1. So 3 comma 1 is here. And it's like, well, maybe if I plugged in, say 1, if I plugged 1 in, I'd get 1 comma 3. So this tells us what this side looks like. I'm pretty sure it's going to be the same on the opposite side, but just for sake, let's plug -1 in to take a look. 3 over -1 is -3. So -1, -3 is down here. So yes, this branch will look similar to this. Again, these are called hyperbolas. It's just a fancy name for a rational function. Any questions so far? Seem okay? All right. Okay, vertical asymptote. Yeah, if x equals 0, that's a bad thing. This has a degree of x to the 0. This has a degree of x to the first. The degree on top is less than the degree on bottom, so y equals 0. So this one should say that it's not going to cross the x or the y axis, just because those are our asymptotes. And again, let's think about if we do a little t-table and plug in values. So I don't know, plug 1 in. If I plug 1 in, I get 2 over -1, so it's -2. So 1, -2 is down here. So that would say that this is going to look like this. And then if I were to plug -1 in, I'd get -2 over -1, which is +2. So 1, +2. So notice what this one did. It flipped locations. It went from quadrant 1 to quadrant 3 to quadrant 2 and quadrant 4. And the reason why the big switch took place is we had the negative right there. Pretty straightforward. The hard thing is if you graph these on your graphing calculator, your graphing calculator doesn't know how to pick up and draw the asymptote in place. So it kind of looks like a heartbeat monitor, an EKG. It goes beep. So it goes up and then comes straight down real fast. So where it comes down real fast is basically where the vertical asymptote takes place. If you did it on Desmos, Desmos will indeed do it without having to worry about breaking it up. All right, so summarize the effects of change on the graph. If a is greater than 0, it's going to make it grow faster, vertically faster. If a is less than 0, it'll switch quadrants. So what I mean on this one, so on this one, you would probably have something like this, whereas on this one, it would switch the quadrants. Okay, so as the absolute value of a gets larger, the hard thing to see is it just basically makes it grow steeper faster. And it's really hard to look at when you're looking at the graphs going, they look the same. Well, if you looked at the table from the graph, it might make some sense of what's happening with a value. This is not the most vital important thing on this part of the thing. But if you look at the t-table, you're going to do fine. So Consider this function, y equals 3 over x minus 4. So our domain basically takes place as x approaches infinity. As I go to the right, what happens to the value of the function? Well, as x grows bigger and bigger, we approach the horizontal asymptote. When you're in pre-calc, they'll call this a limit. Okay, and a limit can be positive, negative, or both, meaning where you approach something. It's kind of like an asymptote. You get closer and closer and closer to something. Do you ever get there? Not really. What about with x equals 0? Well, if x equals 0, that means that my y value is going to be 3/4. Okay? If I plug 0 into the original, that's going to take place. So this one has a vertical asymptote at x equals 4. So it shifted to the right 4 because of how the denominator, that's where the denominator becomes equal to 0. And as we go to negative infinity, we approach the horizontal asymptote as well. And I'm abbreviating asymptote. Seem okay? Not too impossible yet? Okay. These are just general rules for what's taking place. And again, these are also general rules where things take place. So let's graph this. Vertical asymptote, x equals 4. The reason I know that, that's where the denominator would become 0. And then if we look at this, I know that this is x to the 0 here. This is x to the first. Degree on top is less than degree on bottom. So I get y equals 0. So we still have this taking place. Are there roots? You know, this is where it crosses the x-axis. And in this case, I would say no. But we do have a y-intercept. The y-intercept is 0 comma something. So if I plug 0 in here, I don't get a 0 in the denominator. So I get negative 2 over 0 minus 4, which is negative 2 over negative 4, which this week should reduce to 1/2. And that'll kind of give you the point to, hey, this is going to look something like this and something like this. Okay, how did I know that the left looked that way? Well, I saw where it crossed the y-axis, so it kind of gave me the guide of what the graph's going to look like with 0 or 0 comma half. The reason why it flipped over to the opposite quadrants, this negative made a big difference. And then rewrite the function so that y equals single rational expression. Oh, okay. So, vertical asymptote, x equals 3. Agree? So that's here. The degree on top and the degree on bottom, the degree on top is less than, but I have this 2 right here. So what do you think the horizontal asymptote becomes? 2. So it shifts up. And this one, it is very possible to get roots. The reason why we get roots is because the horizontal asymptote moved up. So if I go 0 equals 1 over x minus 3 plus 2, Subtract 2 from both sides. I'm going to run out of room because I'm a horrible person. I can literally flip over both sides. So I'm going to get x minus 3 equals negative half. I just flip both sides over. And then if I add 3 to half, that would be plus 6 halves. So x equals 5 halves, which is about 2.5. So I get about right there. So that'll tell me that down here is this branch. And then I have to be the vertical angle. There's your geometry term for today over here. So what took place on that is the plus 2 changes the horizontal asymptote. We can get the roots pretty easily by putting y or 0 in for y. If I wanted to get the y-intercept, I'm going to plug 0 in for x. So this would give me y equals negative 1/3 plus 2, which in this case should be 1 2/3. So 1 2/3, let's just pretend I could draw that really well, is right there, and I'll just put that as the point 0, comma 1 2/3. And then here comes the hardest part of the whole lesson. Ready? I'm just kidding. I'm being sarcastic. We already did this in this last unit. Rewrite the expression so that y equals a single rational expression. So I'm going to put that over 1. So I'm going to go 1 over x minus 5x over x. So y equals 1 minus 5x all over x. So that takes place right there. The second one, we can also write this as a expression. I'm going to multiply this by x minus 2 and x minus 2. So on top, I'm going to get 3 plus 4x minus 8 over x minus 2, combined like terms. So I get 4x minus 5 over x minus 2. So that's just getting a common denominator, adding them together so you can put it over one term. All right, so 11F. Let's not give you too much homework tonight. Oh, come on, we want a lot. Let's see, what do we have for 11? Oh my goodness, a front, back, front. I would think if we did 11F, I think if we went through and did 1 through 17 odd, that might be a really good thing. Sound good? Yeah, the rest of the period to work on it, and I got done early. Hee-haw. Time for ice cream.